Hello friends, in this video we will learn about freely falling objects. So let us say you are on the top of the building and you drop a ball. What happens to this ball? So once you drop this ball from the top of the building, it goes in the downward direction and finally come to the surface of earth. And why this happens? This happens because Earth has a tendency to pull everything towards its center, and we'll call a term gravity. So the pulling of everything towards the center, and for that I will use a word called gravity. So I can say basically this ball is falling under the constant gravity, and that's why this ball is going in the downward direction. So ball is falling under constant gravity. Now what will happen if I drop two balls? One is lighter ball, another is heavier ball. And this was an important question in the past years, and many philosophers has basically undertaken such kind of questions. So they pondered over these questions. So whether the heavy object will come first or lighter object will come first or both will come at same time, this kind of argument has been given in the literature in the past. Probably it was the Aristotle who was the first person or who was the first philosopher who said heavy object will come to the earth first. So heavy objects or heavy bodies fall faster than the light bodies in proportion to their weight. So he said if you have an object that is heavy, it will move with a fast rate. So its velocity will be fast and it will come to the surface of earth first, and then the lighter object will come. So this means earth has a tendency to pull the heavier objects with a greater rate and lighter objects with a smaller force. So it looks like the heavier object will take less amount of time to come to the earth's surface and lighter object will take more time to come to the surface of earth. But this philosophy did not lasted for a long time. Then Galileo came and he said a body or an object should fall with a downward acceleration that is constant and independent of weight. So he said if you have two objects with different masses or different weights, they will come to the earth's surface at same point of time. This means it does not matter what is their weight. Aristotle said it depends upon the weight. You have more weight, it will come faster. It will move faster, it will come to the earth's surface first. But the Galileo is basically saying reverse. He is saying no, it is not the case. All objects falls with a constant gravity, that is constant acceleration, and they all come to the same time on the earth's surface. Now the science and experiment has basically proved this, that Galileo was right at that point of time, that all objects move with a constant acceleration, that is gravity, and they all will come to the earth's surface at same point of time. This is a proven fact, and this can also be proved by some experimental observation that can be done in the lab. Remember, this is true only for constant gravity case, that is constant acceleration case, and this only happens if you are near to the earth's surface. If you are very far away from the earth's surface, you don't have constant acceleration. So constant acceleration happens if you are close to the earth's surface. For example, this is the earth, and let's say if you drop some ball from this height is h, and this is the radius of earth. Now if this height h is much less than the radius of earth, what is the radius of earth? This is around 6400 kilometer. This means if you drop a ball, let's say 100 meter, 50 meter, 500 meter, or at max you have some kind of activity on the earth's surface that goes up to 1 kilometer. In that case I can say h is in fact much less than r, and then I will assume the gravity is constant. So in this case, g value, that is gravity, that is basically constant. Now as you increase the height, this means as you drop a ball from much height, or in other words, if you do some kind of activity on the earth's surface that is not in the range of 1 kilometer, that is far away from the surface of earth. So this is the point, and there you are basically dropping a ball from this side or some other kind of activity, satellite or something like that. This height, let's say this height is h, and this height is comparable to radius of earth. So this height is approximately same as, or I can say h is not much less than, h is less than r. In that case, I cannot assume that gravity is constant. So this height can be, let's say 3 kilometer or 10 kilometer or 100 kilometer. In that case, if h is 100 kilometer, r is basically 6400 kilometer. So this distance is comparable. So if the distances and h and r is comparable, then I can say gravity is not constant. So g in this case is not constant. So you remember when we say that the object will fall with constant gravity and they will come to the surface of earth at the same point of time, this is true only if you are basically dropping a ball at relatively a smaller height that is not comparable to the radius of earth, that is much less than the radius of earth, and we also ignoring the effect of rotation of earth. So in this video or in this chapter, we will ignore the rotation of earth. So basically earth is also revolving. So this also causes, or this also affects the motion, something that is falling on the earth's surface. So we are ignoring the earth rotation. So if the distance of ball is small, that is this thing, compared to the radius of the earth, so radius of earth is this, that is 6400 kilometer, and if we ignore the small effect due to earth rotation, the acceleration is constant. So when we can assume that acceleration is constant, we have to satisfy two conditions. The first condition is h is much less than r. And the second condition is we have to ignore the rotation of earth. So if we ignore this fact, then I can assume g is constant. But if I have to account for large height and rotation of earth, in that case I cannot assume that gravity is constant. So g value will be different, and it will be a function of height. So if you are at this height, you will have different g. At this height, different g. At this side, different g. At this side, different g. So basically earth will apply different amount of force depending upon your location. If the height is much larger, or you can say height is comparable to the radius of the earth. So we will make these idealization or these assumption for further treatment of the subject. So if I want to simplify the problem, we will assume that gravity is constant and we will ignore the rotation of earth. So the idealized motion that results under all these assumptions is called free fall. So what are the assumptions? First is the motion is happening close to the surface of earth, and also we are ignoring the earth rotation. So these are the assumptions. So if we assume this, then I have idealized motion, and of course we are also neglecting the air pressure or air resistance. So air also has a resistance to the objects. So we are ignoring any kind of air resistance. That is another assumption. In that case, the idealized motion is called free fall, although it includes rising as well as falling motion. So when we throw a ball from top, this is a fall, but if I basically throw in the upward direction, that is basically rising of the ball. So when we say free fall, this includes both. Either you are throwing up or you are throwing down. So free fall is a relatively general term, and it includes rising as well as falling motion of the ball. Now let us try to look closely the experiment in the opening of this video. That is, you are dropping a ball from the height top of the building. So let's say at t is equals to 0, you just drop this ball. So this starts going in the downward direction. And what you are doing is, you are taking a snapshot, or you are taking basically photo of the falling ball at equal amount of time. So this means you are basically clicking your camera and you are taking photographs. So these snaps are taken at different times. So this is time t1, this snaps is time t2, t3, t4, t5. So what we are saying, these all snaps are taken equal interval of time. For example, this is taken at 0.1 second, this is at 0.2 second, this is at 0.3 second, and this is 0.4 second, and this is 0.5 second. Similarly, you have the photographs for different time intervals, and in each case the time interval between two snapshots is 0.1 second. So you see, the time interval in each case is 0.1 second. Now if you look closely, one important point, then each a small time interval, the distance traveled is not same. In this case, only this much is the distance. In this case, there is a larger distance, and in this case even more. So the distance traveled between two successive flashes. Time is same, delta t is same for all the flashes, but delta x, or you can say delta y, that is the difference between height, is not same. Delta y is increasing. Here you have larger distance and here you have a smaller distance. So as the ball is going in the downward direction, delta y is increasing. What that means? If you remember, what is the velocity? Velocity is nothing but delta x. If I talk in terms of average velocity is delta x, or in this case delta y, divided by delta t. So as delta y is increasing with time, I can say average velocity is increasing with time. So here I have a small average velocity and here I have larger average velocity. I can say average velocity has increased at this point of time. So average velocity is increasing. This means acceleration is also, this means we have an accelerated system. So there is acceleration. So velocity is changing. If velocity is changing, then we can calculate acceleration. If you remember, we have formula for average acceleration. This is nothing but change in velocity divided by change in time. That is time interval. And these all are vector quantities. So now velocity is changing. So delta v, velocity is changing. I have a different average velocity at this point and different average velocity at this point. This means I can calculate v2 minus v1 divided by t2 minus t1. So there we have average velocity v1 and here I have average velocity v2. Then I can write v2 minus v1 divided by t2 minus t1, that is delta t, and that is your average acceleration. Now from experiment, it is found that this average acceleration remains constant. So if you drop a ball and you basically measure the height of the ball at different instant of time, and you can calculate average velocity and you calculate the average acceleration, then you will find the acceleration value remains constant. What this means? This means you can calculate average acceleration using these 2 points, you can calculate average acceleration using these 2 points, or you can calculate average acceleration using these 2 points. How will you calculate? You know velocity at this point v1, velocity at this point v2, so I will take v2 minus v1 divided by delta t. Here also you know the velocity v1, you know the velocity v2, v2 minus v1 divided by delta t, that will give you the acceleration. So we found that acceleration between these 2 points, acceleration between these 2 points and acceleration between these 2 points always comes to the same value. This means acceleration remains constant, and we call this acceleration as a gravity, acceleration due to gravity. So acceleration due to gravity is constant. So I can summarize this experiment. So in this experiment you will find equal time interval between flashes. So what we have done is we have considered time interval between two flashes is same. So when we are clicking first and the second, the difference between time interval between any two consecutive flashes is same. And what is the result? Increasing distances between images so that the velocity is continuously changing and the ball is accelerating. So from this figure we find that the distances between two successive time intervals is increasing. So this means ball is accelerating in the downward direction, and we found this acceleration value is a constant value, and we call this as a acceleration due to gravity, and simply we denote by z. And remember, this gravity is acting in the downward direction. So it is possible to measure the acceleration due to gravity using such experiment. So we have done a very simple experiment, and using this experiment you can measure the acceleration due to gravity. There are more sophisticated experiments that is also possible, and from those experiments you can measure the z. And if you perform this experiment, you will find z value is 9.8 meter per second square. So z is acceleration. So unit of this will be meter per second square. And what is the value? In SI unit, the value is 9.8 meter per second square. Or the same you can say 980 centimeter per second square, or you can say 32 feet per second square. So this is a approximate value if we are close to the surface of Earth. If you go very far away from the surface of Earth, this value will not remain same. This value will be different. Basically, as you go up from the surface of Earth, this g value decreases. Now the concept of gravity is not only true for Earth, it is also true for other satellites. For example, if you go into the moon has a tendency to pull the things towards its center. Then we will call this is the gravity due to moon. And if you go to the sun, you will call gravity due to sun. So the value of z depends upon location, where you are. You are either on the moon, or you are on the sun, or you are on the earth. So if you are on the moon, the z value is very small, that is 1.6 meter per second square. And on the sun, this value is very large, that is 270 meter per second square. This means sun has a more tendency or higher pull forces to pull some things towards the center of the earth, center of the sun. The magnitude of z is always taken positive. So you see, the z is always acting towards the center. So we'll assume that this is a positive, and sign we will see that will come from the coordinate axis. So if I am choosing my coordinate axis is in the upward direction, if I am choosing my coordinate axis is in the upward direction, that is positive y-axis is in the upward direction. So gravity is acting in the downward direction. So in that case I will say the gravity is z, magnitude is z, but the sign is in the downward direction. So I will put a negative sign here. Now I will illustrate whatever we discussed here using a problem. So this problem says a 1 rupees coin is dropped from the Leaning Tower of Pisa and Philip falls from rest. What are its position and velocity after time of 1 second, 2 seconds and 3 seconds? So the first thing is, you see in this problem there is a word called free fall. So what is the meaning of free fall? So when we say free fall, this means this is moving with constant acceleration. So this is moving with constant acceleration. and this constant acceleration value is simply z, and that is acting in the downward direction. Now if you remember, in the previous chapter we derived few formulas, that is constant acceleration case. So you can basically calculate distance, velocity, if you know that this acceleration is a constant acceleration. So if you remember, for constant acceleration we have formulas, that is one dimensional motion equations, that is s is equals to ut plus half at square, and v is equals to u plus at, and v square is equals to u square plus 2as. So these are the three kinematical basic equations that we developed in the previous chapter, that works only if acceleration is constant. So in this case, constant acceleration is constant, then only these formula work. Now this problem is a free fall. This means acceleration is constant and the constant acceleration value is z. So now I can apply this formula. That is the advantage. So what are the things that we have to find? We have to find position. So we have to find position. And then we have to find velocity. And this we have to find as a function of time, that is a different point of time. So now how will you solve this problem? An initial velocity is 0 because this has given that this has been simply dropped. This means you are not throwing in the downward direction, you are simply dropping. So if you are simply dropping, this means initial velocity is 0. To solve this problem, first I have to set a coordinate system. So initially my coin is somewhere here. So this is the position of the coin. Now this coin has been dropped in the downward direction. So generally we put our origin of the coordinate system from where the motion starts, from where the ball has been dropped, or from where the coin has been dropped. So this will be my origin. So this point is origin. So generally we denote word O, this means origin. Now generally the y-axis is taken in the upward direction. So this is my y-axis, that is positive direction. So this point is origin, and this bi-direction, that is y-axis, is in the upward direction. And since this motion is along a straight line, I need only one coordinate system, only the y-coordinate system. So let us try to find what is the acceleration. Once again, acceleration will only be in the downward direction, and the value of this acceleration is z, but this is acting in the downward direction. My positive direction is in the upward direction, so I have to put a value of minus. So negative z is the acceleration. What is the initial velocity of coin? So coin has simply been dropped, so I can write uy is equals to 0. That is, initial velocity in the y direction is 0. Now I can use this formula to find displacement and velocity. So what is my target value? My target is to find what is the position, what is the velocity. So at certain point of time, so let's say this is falling in the downward direction, and at certain point of time this coin is here. So this is the position of coin at certain point of time. So this height, that is this height is y. So we have to find what is this height y, and also we have to find what is the velocity at this point of time. So with what velocity this coin is moving in the downward direction. So let us write s is equals to ut plus half at square formula for this motion. So what is the distance? Distance is y. So this s. What is the initial velocity? That is ut plus half at square, and since I am talking about the y-axis, I can put a subscript y. So what is the initial velocity in the y direction? 0. So half, what is the acceleration? Acceleration is simply minus g t square. So now I can write y is equals to minus half gt square, and g is nothing but 9.8 meter per second square, and this is t square. So this becomes minus 4.9 meter per second square t square. So this is my y value. Similarly, I can write velocity in the y direction, that is u plus at, and I have to plug the subscript because I am considering motion in the y direction. So what is the initial velocity in the y direction? Initial velocity is 0 and acceleration in the y direction is minus g and time t. So this becomes minus 9.8 meter per second square time. So this is nothing but minus 9.8 meter per second square t. So this is the expression for velocity. So now I know position and velocity as a function of time. So in the problem it is said we have to find y value for t is equals to 1 second, t is equals to 2 second and t is equals to 3 second. So let us try to find for t is equals to 1 second. So I can calculate y value for t is equals to 1 second. What I have to do? I have to simply plug t is equals to 1 in this expression. So let us find this value. So y is equals to minus 4.9 meter per second square t square. So I have to plug 1 in place of t. So this will be 1 second whole square. So this will be nothing but minus 4.9 meter. Similarly, I can calculate Vy, and the expression for Vy is nothing but minus 9.8 meter per second square, and this multiplied by time. So in this case time is 1 second. So minus 9.8 meter per second square multiplied by 1 second. So if you calculate this, this will come minus 9.8 meter per second. So we calculated the position and velocity at 1 second. Now similarly I can calculate for t is equals to 2 second and t is equals to 3 second. So if you do this, for t is equals to 2 second, you will find y is equals to minus 20 meter. And velocity in the y direction, that is Vy, that you will find that is coming minus 20 meter per second. And for t is equals to 3 second, you will find the y value is minus 44 meter and the velocity is minus 29 meter per second. So you see one important point, the y in all cases is negative. So y is minus 20, minus 44, minus 4.9. So this also means the y is opposite to the axis. So y axis is in the upward direction. So you will have somewhere here, that is 4.9, 20 somewhere here, and this is minus 44 somewhere here. So y is opposite side to the origin, that is opposite side to the y axis. That's why y we are getting is negative. Also the velocities are negative. This means velocity negative means this is acting in the downward direction. So my velocity is in the downward direction. Since I have chosen my axis, positive axis in the upward direction, velocity is acting in the downward direction. So in this video we learned about free fall objects, freely falling objects. In that case, how do you calculate different instant of time, what is the velocity, what is the distance of the object, and you can use constant acceleration formula for solving such problems. And whatever the theory we discussed, that basically makes some assumption. One assumption is your ball is not very far away from the surface of earth. Another is earth rotation has been neglected, and we have also assumed air resistance are not that much. So we are ignoring the air resistance. So if you use all this idealization, we can make a model or we can make a theory for freely falling objects based upon the constant acceleration case. And this constant acceleration is nothing but gravity. And once I know the value of gravity, I can calculate displacement, velocity at different instant of time. I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you. Hello friends, in this video I will do a problem on motion under gravity. So this problem is called up and down motion in free fall. So the problem says you throw a ball vertically upward from the roof of a tall building. The ball lifts your hand at a point with an upward speed of 15 meters per second. The ball is then in free fall. On its way back down, it just misses the railing. Then we have to find the first part of the problem says the ball's position and velocity at t is equals to 1 second and 4 seconds after leaving your hand. So we have to find ball position and velocity at t is equals to 1 second and t is equals to 4 seconds after this ball leaves your hand. So basically this is the ball here we have, and this is the tall building, and this ball is thrown vertically upward. So this will go in a straight line in the vertical direction. Basically there are many possibilities. You can throw this ball like this or like this or like this or like this. If you throw any one of the direction or any one of the orientation as shown, this ball will follow a parabolic path, something like this. And this is an example of projectile. In that case you will have two direction motion, x as well as y, and then you have to basically solve for x as well as y. But in this case problem is relatively simple, and this is only one direction motion. So ball is thrown vertically. So what will happen? The ball will go up in a straight line and it will follow the same straight line and it will come down to the ground. So if I show the same thing, I can show this ball is going up. So it will go up, and at a certain point of time it will have zero velocity in the vertical direction, and then the ball will start coming down. So this ball is coming down. So this is the path of the ball. So this is going up and then this is coming in the downward direction. So this is the path of the ball. Basically I am showing here two lines, but in fact there will be only one line. So the ball will go in the same path and it will fall in the same path. So there is only one straight line. Just to illustrate, I have shown here two straight line. The path that I have shown separated is exactly same path in actual situation. And the question says this ball is under free fall. So this is under free fall. So when I say free fall, what does that mean? This means acceleration is due to gravity. So this means this ball this ball will experience an acceleration, and that is value of z. So this is acceleration due to gravity. So if you see, let's say initial velocity that is given in this problem. So u by that is 15 meter per second. So this ball has been thrown at a speed of 15 meter per second. As ball will go up, its velocity will decrease. Why? Because earth is trying to pull this ball. So gravity is acting in the downward direction. So its velocity will reduce. So ball will slow down, and eventually at the top point this ball will come to the rest. And then the ball will have downward velocity. So downward velocity will start increasing. Why? Because the ground is pulling this ball. So the velocity in the downward direction will increase, and finally this ball will come to the ground. Now we have to find position and velocity of this ball at different point of time. So to solve this problem, first we have to identify an axis, and since this is a one-dimensional problem, we need to have only one axis. So let us define y-axis, because this is a vertical motion, so we can define a y-axis. And generally the origin is taken as the point from where the object starts the motion from rest. So this is the point from where the ball starts the motion. So we will take this axis, that is the vertical axis, is the y-axis. So this is my y-axis. This means positive direction of the y-axis is in the upward direction. What will be the gravity? Gravity is acting in the downward direction. So gravity is basically negative. So I can say initial speed, that is u by, is equals to 15 meter per second, and this is positive. Now what about a by, that is acceleration in the y direction. Acceleration is acting downward, so this is minus g, that is minus 9.8 meter per second square. Now once I know initial velocity and acceleration, I can apply formula for constant acceleration to calculate position or y of the ball, so distance of the ball from the origin. So if you remember, we have a formula something like this: s is equals to ut plus half at square, and this formula can be used to calculate distance of the ball from the origin. So let's say if I write the same expression for y-axis, we can write y is equals to u by t plus half, and acceleration is a by in this case, and t square. So let us plug this value. So y is equals to initial velocity is 15 meter per second times t plus half, acceleration is nothing but 9.8 with a negative sign, meter per second square, and times t square. So y will be 15 meter per second times t minus 4.9 meter per second square, and this is t square. So this is the expression for y. So if I plug the value of t in this expression, I can calculate y. Now similarly, I have to also calculate velocity of this ball at different point of time. So you may remember formula v is equals to u plus at. And if I write this formula for y direction, I can write v by is equals to u by plus a by times t. So I can write v by is equals to u by is given, that is 15 meter per second, plus a by is nothing but minus 9.8 meter per second square, and this multiplied by time. So now I can basically calculate by, that is position, and v by, that is velocity of the ball at different point of time. Let us calculate these two at t is equals to 1 second. So if you calculate this for t is equals to 1 second, that is you have to put t is equals to 1 here and t is equals to 1 here. You will find y is equals to 10.1 meter. And similarly v by will be, that is you put t is equals to 1 here, then you will find vy is equals to 5.2 meter per second. So you see, in this case, basically y and vy both is positive. So this is possible only when the ball is going in the upward direction. So what is y? Y is 10.1 meter. So I have started from here. So ball is somewhere here. So t equals to 1 second, ball is somewhere here. That is distance of 10.1 meter, and the velocity is in the upward direction. So this is the position of the ball, and this is the velocity of the ball. Now we can also calculate at t is equals to 4 seconds. What I have to do, I have to simply plug the value of t in this expression, that is equation 1 and equation 2. So if you plug this value, you will find y is equals to negative 18.4 meter. And vy is equals to negative 24.2 meter per second. Now you see, in this case, both the y coordinate as well as velocity, both are negative. This means ball is in the returning journey. This means ball has basically reached to the highest point, and then this is coming down. And how much down? This is 18.4 meter. So from 0, so this is my origin, so this is origin line. So from here, this ball is somewhere here, and this distance is 18.4 meter, and the velocity of the ball is in the downward direction, and the magnitude of velocity is 24.2 meter per second, and this ball is going in the downward direction. So this is the situation at t is equals to 4 seconds, and this was the situation at t is equals to 1 second. One more important point in this case, you can see that Vy, this value has increased significantly. Initial velocity was 15 meter per second. Now this value is 24 meter per second. So 24.2 meter per second. Why this happened? Because of the gravity. So gravity is basically pulling this ball in the downward direction and increasing the speed of the ball, and that's why the speed of the ball has increased, and this is now 24.2 meter per second. Now let us do the second part of the problem. So this part says we have to find the ball's velocity when it is 5 meter above the railing. That is above the railing. So this is my origin. So this is the railing point. Above the railing, this means somewhere here 5 meter. This means y is equals to plus 5 meter. And what we have to find? We have to find velocity, that is Vy. So distance is given and we have to find velocity. Of course, acceleration is also known to me, and in this case acceleration a by is equals to minus g. So which formula you will use? You will use v square is equals to u square plus 2as. So this is a formula for constant acceleration, kinematical formula. I can write same formula for bidirection, and in that case I will write v by a square is equals to u by a square plus 2a by, and distance s will become distance in the y direction. So we can write v by a square is equals to u by is known to me, that is 15 meter per second, a square plus 2, and acceleration is minus 9.8 meter per second square, and this multiplied by is known, that is 5 meter. So from here you can calculate v by, and this if you calculate, this will come plus minus 11.3 meter per second. So you see there are two possible velocity, one with a positive sign, another with a negative sign. What does this mean? This means one velocity is in the upward direction, the positive one, and negative one is in the downward direction. So this means the distance 5 meter is reached when there are two possibilities. Let's try to see this. So this is the path of this ball. If you remember, this is the path of this ball. Let's say this height is 5 meter. So when the ball is going up, it will have a distance of 5 meter from the origin, and in that case velocity will be 11.3 meter per second. And this ball will come to the 5 meter once again, that is the returning journey. So this is downward journey. At this point of time again, this ball has a height of 5 meter. So this time this has a velocity in the downward direction, and the magnitude of velocity will be same, that is 11.3 meter per second. Only thing is this velocity is acting in the downward direction. So velocity direction has reversed, but the magnitude of velocity is same for a given y. In this case y is equals to 5 meter. And the third part of the problem says we have to find the maximum height reached by the ball. So basically this ball is going in the upward direction, and then it will come to maximum height, and then this ball will start going in the downward direction. So we have to find this height, that is the maximum y. What is the maximum y that this ball can take? How we will find this? So important point, when we have maximum y, this means y velocity is no longer more, otherwise it can go further. So this means velocity in the y direction is 0. So we will use this fact, that is Vy is equals to 0, and then from there I can calculate what is the maximum height that this ball can go. So we will use the same formula, that is v square is equals to u square plus 2as, Now if I write for the by motion, I can write v by a square is equals to u by a square plus 2, and acceleration in this case is minus g, and s is nothing but by max. So what will be Vy? Vy will be 0 as I said, and u by is nothing but 15 meter per second, and this is square plus 2 times minus 9.8 meter per second the square, and this multiplied by max. So from here I can calculate by max. So by max will be, this is equals to 11.5 meter. So basically ball can go maximum up to a height of 11.5 meter. And the last part of the problem says, find the ball's acceleration when this is at its maximum height. So when we have by is equals to by max, that we have calculated just, so this value is 11.5 meter. So at that point of time, what is the ball acceleration? So this is generally a misconception. A student often think that at highest point, so when the ball is at highest point, the v by is 0 as well as acceleration in the by direction is also 0. This is not the case. A by is not 0 when ball is the highest position. Acceleration in the by direction is always acceleration due to gravity. So this is always fixed. A by is equals to z with a negative sign. This means A by is always acting in the downward direction. Whether the ball is at rest or whether ball is at the maximum height or somewhere in the middle of the path. A by the acceleration of the ball will always be equal to minus g. So do not have this confusion in the mind whenever you are doing some problem related to motion under gravity. Now we can try to plot the velocity and position of this ball with time. So we calculated the expression. So let us try to plot y and Vy as a function of time. So if you remember, we calculated or we determined the expression for y. So what was the expression? Y is equals to 15 meter per second. This expression we calculated in the first part, times t minus 4.9 meter per second square, and this multiplied by t square. So this was the expression for y as a function of time. Now I want to plot this function. How we can plot? So let us say this is my y-axis and this is my x-axis. So on the x-axis I have time, on the y-axis we have distance from the origin of the ball. Now this is an equation of parabola. Basically you can plot by taking different value of t and you can calculate different values of y. So what you have to do? You have to plug the values of t and you have to calculate the values of y, and then you could plot the graph. So for different t, what is the value that is coming? For example, if you put t is equals to 0, y is equals to 0. So t equals to 0, y is equals to 0. And then you can also find other time what is the value of y, and then you can plot this graph. Now since I know that this is a graph of parabola, so this graph will be something like this, because this is a graph of parabola, and where this will end and this will end at the ground. This means this is the height, that is the height of the building, that is h. This is the graph of the parabola, and what is this height? This is the maximum height of the ball, that is by max, that we calculated in the first part. What was the value? That was 11.5 meter. So this is nothing but 11.5 meter. Similarly, I can plot velocity as a function of time. So if you remember, Vy is equals to 15 meter per second. This expression we calculated in first part of the problem, minus 9.8 meter per second square, and then times. So this was the expression that we calculated in part A. Now can you tell me what is this expression? So this is the equation of So this is the equation of a straight line. So this is the equation of a straight line. So let us plot this. On the y-axis we have v by, and on the x-axis I have time. Now when you put t is equals to 0, what is v by? When t is equals to 0, Vy is nothing but 15 meter per second. Now this is a straight line, and what is the slope? Slope is negative. So this is a straight line and slope is negative, and this line is passing through this point. Then this means I have this graph. So this is the graph of Vy versus t. Basically you can find this time. What is this time? At this point of time Vy is equals to 0. So if you plug in this expression Vy is equals to 0, you can find time. So this is equals to 15 meter per second minus 9.8 meter per second square, and this multiplied by time. So from there you can calculate time, that is 15 divided by 9.8 second. So this time is nothing but t naught. Let's call t naught is equals to 15 divided by 9.8 second, and that is equals to 1.53 second. So this concludes this problem. So in this problem we have seen, if you throw a ball vertically up, how you can calculate the different point of time, what is the position of the ball, what is the velocity of the ball. And you can also calculate for a given y what is the velocity. In that case we have seen there are two possibilities, one for the upward journey and another for the downward journey. And finally we also plotted y versus time and velocity versus time. In one case the graph is parabolic, in another case this graph is a straight line. I hope you enjoyed this video, and if you like this video, please share with your friends, and I will see you in the next video. For the time being, thank you, bye, take care. Hello friends, in this video I will do a problem on motion under gravity, and this problem is called 2 root or 1 root. So the problem statement says, you throw a ball vertically upward from the roof of a tall building. The ball leaves your hand at a point with an upward speed of 15 meter per second. The ball is then in free fall. On its way back down, it just misses the railing. So you have to find at what time after being released has the ball will fall 5 meter below the roof railing. So let us try to see this problem first using a diagram. So this is the tall building that we have, and this ball is thrown vertically up from top of the roof, and there is a railing, and this railing is very small. So this is just going from the corner of the railing or edge of the railing, so that when this ball is coming in the downward direction, it does not go into the railing, it goes outside of the railing. So this ball is thrown vertically up. So this is going in the upward direction. So this is the vertical motion, and after a certain point of time its velocity will be 0 because gravity is pulling this ball. So it will start coming down. So this ball is coming down something like this, and then this ball will fall to the ground. So this is the path of this ball. So finally this ball will be on the ground. So this is upward journey, and this is the downward journey of the ball. So ball is coming downward. Now this is also given in the question that this is a case of free fall. So what is the meaning when I say free fall? This means acceleration of the ball is due to gravity. So we can basically know what is the acceleration of this ball, because this is under free fall. This means we can apply constant acceleration, and that is value of gravity z 9.8 meter per second square. So what are the things that is given? So we have been given initial velocity, that is this ball is thrown in the upward direction with a velocity of 15 meter per second, that is uy is given. And what is else that is given? We know ay, that is acceleration, and that is z, 9.8 meter per second square. Now we have to solve this problem. Since this is a one-dimensional motion, we have to choose a axis, and for that we have to choose first origin. So origin will be this, because generally we choose origin from where the motion takes place, where the motion starts. So from rest, this ball starts its motion from this point, so I can consider this is origin and this is the y-axis. So y-axis is in the upward direction. So anything that is in the upward direction will be taken as positive, and anything that is in the downward direction will be taken as negative. For example, acceleration due to gravity is in the downward direction, so this will be negative. But the velocity is in the upward direction, so this will be positive. Now what we have to find? We have to find time after which, basically after being released, the ball will fall at a distance of 5 meters below the roof railing. So basically, what is the position of ball? The position of ball is, this is the roof railing, so this is the origin. From here, this ball is 5 meters below. So this distance is given. So y value is given, that is 5 meters below the roof railing. And this is the level of roof railing that is on the origin. So this is the level of origin. So y value is given to us. So y is equals to, so this is positive or negative? This is negative because y is the downward side. So y is equals to minus 5 meter. And what we have to find? We have to find what is the time when y is equals to minus 5 meter. So how will you find that? If you remember, we have the formula, that is S is equals to ut plus half at square. The kinematical equation for calculating the distance in case of constant acceleration case. Now we can use this formula for y direction. Then I can write y is equals to u by t plus half a by t square. And we can also write, since a by is equals to minus g, so I can write u by t plus half, and a by is nothing but minus gt square. Now this equation is basically a quadratic equation in t. I can rearrange this expression. I can take this left side, I can write half z t square, and this will become negative minus u by t, and plus by is equals to 0. So this is the expression, and this expression is quadratic in t. So this is quadratic in t. Probably you will be knowing that how do you solve a quadratic equation. So basically, whenever you have a quadratic equation, there are two roots. For example, if I have a quadratic equation ax square plus bx plus c is equals to 0, there are two roots of this equation, and this is x is equals to minus b plus minus b square minus 4ac divided by 2a. So this is the expression we have, that is the root. Now what is the value of a in this case? In this formula or in this equation, a is equals to simply half z. And what is the value of b? B is nothing but minus u. So b is equals to minus u by. And what is c? C is equals to by. So c is equals to by. And this expression is quadratic in t. So basically I have to replace x with time t. So what will be the root in this case? So I can write t is equals to minus b, that is minus of minus u by. So minus of minus u by, that is b is equals to minus u by, minus b plus minus b square is nothing but minus u by whole square minus 4, and a is nothing but simply half z, and this multiplied by c, c is by, and this divided by 2a. So this is the expression for time. So I can calculate time. So let us simplify this. So this will be u by plus minus u by s square minus 2z by, and this divided by z. So this is the expression for time. If I know the by, u by z, we can calculate time. So let us calculate this value. So we have t is equals to u by is given, that is nothing but 15 meter per second, plus minus u by is 15 meter per second whole square minus 2, and g is nothing but 9.8 meter per second square, and then by is known, that is minus 5 meter, and this divided by z, and g is nothing but 9.8 meter per second square. So if you solve this, you will find two value of t. So two roots of t. One is t is equals to 3.36 second, and another value that will come, t is equals to negative 0.3 second. So these are the two roots that we have for this equation. Now we have one root that is negative. So in this case, if you see, this root is negative. So negative root has no physical meaning. So there is no physical meaning in this case. So no physical meaning. So basically I have to neglect this root, or I have to discard this root. Basically what this says, t is equals to minus 0.3. This basically signify a time that is before the throwing of the ball. So 0 is the time when we throw the ball. So this is the 0.3 second before throwing of the ball. That does not make any sense. So in this case, I can say we have only one solution or one root, that is t is equals to 3.36 second. So ball will be at a height of 5 meter below the original position, that is by equals to 0, at a time of 3.36 second. So I can say y is equals to minus 5 meter. This height will be reached at t is equals to 3.36 second. Now you can also calculate for y is equals to plus 5 meter. The same expression I can use, only thing is I will replace y with plus 5 meter. In that case, if you calculate time, you will get time is equals to 2 time value will get, one is 0.38 second, and other value of time that you will get is 2.68 second. Now you see, in this case both roots are positive. So this means I have to consider both. Both root has physical meaning. Why this is so? Because in this case this ball is going up and then coming down. So this is the path of this ball. So y is equals to plus 5 meter. So y is equals to plus 5 meter is somewhere here. 5 meter. So one time corresponds to upward journey. So this is 0.38 second, and other corresponds to downward journey. So basically the ball is at t is equals to 5 meter at 2 point. One corresponds to 0.38 second, that is upward journey. So upward journey, ball is at a distance of 5 meter, and this corresponds to 0.38 second. And when the ball is coming in the downward side, once again time is equals to 2.68 second. The ball is at a height of 5 meter. So in this case I can say both root has meaning. Now you can also calculate what will be the value of time when you have y is equals to 11.5 meter. So let's say, so with two cases we calculated. In one case we have one root negative, in another case both root is positive. Now let us consider third case, that is y is equals to 11.5 meter. In this case, if you calculate time, you will find there is only one root. In other words, we can say both root are same, that is the equal root. You are getting an equal root. In that case you will find t1 is equals to t2, and this is equals to 1.53 second. Basically, I have calculated this in the previous video. Now see, this point basically corresponds to the highest point. So T1 is equals to T2, and that is same. This corresponds to the highest point. So you see this ball is going upward and then coming downward. So you see in this case at the top point you will have y is equals to 11.5 meter. And there are two times, one is going, another is coming. This means both times are same, that is 1.53. In other words, you can say one point is 1.52999, another is 1.53. So very little difference. Basically, there is no difference. Just to make sense, I am saying that in one case, one corresponds to upward journey, another corresponds to a downward journey. But in this case, both routes are coinciding. Both routes are equal. And that case, basically, this corresponds to the highest point, the peak point. So corresponding time is 1.53 seconds. So in this video, we have seen whenever you have a y as a function of time, and this is a quadratic expression. So there are three possibilities. One possibility, that is both roots are positive. Another possibility, one root is positive, another root is negative. And third possibility, both roots are same and that value is positive. Both root negative has no meaning, and this is not possible because you can't have both root negative. There are only three possible situations. One root positive, another root negative. Positive, negative, this means in that case you have to discard the negative and you have to consider the positive. Both positive, this means one corresponds to the upward journey, another corresponds to the downward journey. Both root equal, that corresponds to the top point when the velocity is 0 and ball is at the highest point. And I hope you enjoyed this video, and if you enjoy and you like, then please share with your friends, and I will see you in the next video. For the time being, see you, bye, take care. Hello friends, in this video we will see how to calculate position and velocity of a particle using integration, and this we will discuss for a particle that is moving in a straight line. This means motion in one dimension. Now discussion of this topic requires little bit knowledge of integral calculus. So I assume that you have some idea of differentiation and integration. Now in the previous videos we have seen how to calculate position, velocity, these terms for a case when the acceleration is constant. Basically, if you have a one-dimensional motion and acceleration is constant, you can apply three kinematical equations to calculate distance and velocity at any given point of time or at any given distance. What was that formula? So if you remember, those formula was, one formula was S is equals to ut plus half at square. So this is one formula, and in this case, remember, acceleration is constant. That is the most important point. In this case, acceleration is basically constant. That is the important point we have. Another kinematical formula that we have, that is v square is equals to u square plus 2as, where u is the initial velocity, a is the acceleration, v is the final velocity, and s is the displacement traveled. We can also calculate v using third formula, that is v is equals to u plus at. Now we can use these three formula to calculate distance and velocity only if acceleration is constant. Now the question comes, what if acceleration is not constant? How we deal with that situation? How we calculate position or how we calculate velocity of the particle at given point of time or at given distance? How we do that? So in this case, I can say if acceleration is not constant, in that case I cannot apply this formula. So when acceleration is not constant, the equation that we derived in that section is no longer valid. So this equation that we derived earlier in the previous video is no longer valid because these derivations assume that acceleration is constant. So now I cannot apply these equations because acceleration is not constant. Then what should we do? In that case, we have to go from the definition of instantaneous velocity and instantaneous acceleration. If you remember, we have derived or we have defined average velocity, that is delta v is equals to delta x divided by delta t. So this was the average velocity expression. Now in the limiting case, when delta t tends to 0, this average velocity becomes instantaneous velocity. So in the limiting case, I can say when delta t tends to 0, this average velocity becomes instantaneous velocity Vx, and this becomes delta x by delta t, this becomes simply dx by dt. So this is the expression for instantaneous velocity. So now when the acceleration is not constant, we will try to work with the instantaneous velocity expression, that is Vx is equals to dx by dt. Similarly, we will work with the instantaneous acceleration expression. Instantaneous acceleration will be Ax is equals to dvx by dt. So this is same expression. Similarly, you can calculate average acceleration similar to average velocity. You can calculate average acceleration. So this is average acceleration, and this is equals to change in velocity divided by change in time. And if you take limiting time, that is delta t tends to 0, then this average becomes instantaneous. So in that case, you will have average velocity, this will become your instantaneous velocity, and this becomes simply dv by dt. So now we have these two expressions. For first expression, this is for one dimensional motion, that is Vx is equals to dx by dt, and the second expression, that is acceleration, Ax is equals to dvx by dt. So now if I know acceleration, then how we calculate velocity? So the first point is, in many situations or in many cases, acceleration as a function of time is known. So in many cases, acceleration is known as a function of time, but not the velocity and the displacement. So if I know acceleration, so in this expression acceleration is known, then what is my target? And acceleration is known as a function of time. Then from here, how we calculate velocity as a function of time, and how we calculate displacement as a function of time. So this is the challenge, how we do that. So my acceleration is known, and this is known as a function of time, and I want to calculate velocity and position vector as a function of time. So the question is, how can we find position and velocity in a straight line motion from acceleration function, that is at? So I know acceleration function, that is at. It can be any kind of function. For example, it can be a linear function a plus bt, or it can be quadratic function. Depending upon the problem, it can have a different kind of function. So if I know this function, how we calculate velocity as a function of time, and how we calculate displacement as a function of time. So this is the idea that we have to solve. This is the problem that we have to solve. To solve this problem, basically there are two approaches. The first approach is graphical approach. So let us say acceleration as a function of time is known to me. So I know acceleration as a function of time. So this is the graph of acceleration as a function of time. So this graph is known to me. Now what is my target? My target is to calculate velocity as a function of time. Now in this graph, on the x-axis we have time, on the y-axis we have acceleration, and this is one dimensional motion, so we have ax. So now let us consider, if you remember, we have this formula, that is average acceleration is equals to So this is average acceleration. So average acceleration in the x direction, if I consider, this is equals to change in velocity in the x direction divided by delta t. I can also write this expression that a change in velocity in the x direction is equals to average acceleration in the x direction multiplied by delta t. So this is the expression, same expression written in a different manner. Now this expression gives me a hint. What is the hint? That is, if I want to calculate change in velocity, then I can multiply average acceleration and delta t. So what I will do is, idea is we have to find some small value of t, that is delta t. So using this idea, let us divide this time interval from t1 to t2 into a small intervals. So what we have? So this is my acceleration time graph. So this is the acceleration time graph. And this graph is given to you from time t1 to time t2. So basically, you know what is the instantaneous acceleration at time t1 and what is the instantaneous acceleration at time t2. Now what we are doing is, we are dividing this time interval from t1 to t2 into different parts. One part is this, one part is this, another part is this. So we are basically dividing time a scale into a small parts. And let's say any small part is called delta t. So this small length of this small time interval is delta t. Then what we will do is, we will make one rectangle. So this is the rectangle that we have. Now for this rectangle, if you see, for this rectangle, the acceleration is not constant. For example, acceleration is varying from here to here. So for this point, this is the acceleration, this point, this is the acceleration. But if we consider delta t is very small, I can assume this acceleration is constant. Or what we can do is, we can use average acceleration. So let's say, I can say for this time delta t, the acceleration is the middle value or the average value. So this corresponds to the average acceleration. So this means for this rectangle, I know average acceleration. So if I know average acceleration, I can multiply by dt and I can get change in the velocity in the x direction. And that is written here. So if I want to calculate change in the velocity, what we have to do is, we have to take average acceleration for that small interval and then I have to multiply by delta t. Now what this term graphically means? So this is average acceleration multiplied by delta t. This term is nothing but area of this rectangle. So this is average acceleration is this much. So this is the height and delta t is the width. So height multiplied by the width, that is nothing but the area of this rectangle. So this term, that is a average in the x direction multiplied by delta t, this term is nothing but area of this small rectangle. So I know what is the change between this time interval delta t, that we can calculate simply by calculating the area of the small rectangle. Now if I want to calculate what is the change in velocity from time t1 to time t2, how we will do that? Idea is again same. What we will do is, we will calculate all these areas. So this area plus this area plus this area and finally plus this area. So if you calculate all these rectangular areas and then sum, then you can calculate change in velocity between time t1 and time t2. So we can write change in velocity in the x direction from time t1 to time t2. This is nothing but sum of all the areas, that is average velocity in the x direction. So average velocity in the x direction multiplied by dt. and this is from time t1 to time t2. So simply if you add all this area, then you can find what is the change in interval or change in the velocity from time t1 to time t2. So the total x velocity change is represented graphically by the total area under the curve between vertical lines t1 and t2. So if I want to calculate what is the change, in that case basically we have to calculate the area. So what is the change between v1 to t1 to t2? So let's say at point t1 velocity is v1 and at time t2 velocity is, let's say, v2. And this is approximated, so this velocity is v2. So this is v1 and this is v2. Now if I want to calculate what is the change, so this means what is v2 minus v1, that is nothing but change in velocity in the x direction, and this is nothing but total area between time t1 and t2. So this is equals to total area between t1 and t2. So if I can calculate this area, I can calculate change in the velocity. So this is the graphical approach. In graphical approach, what is the idea? You basically divide the time axis into a small regions, and once you have a small regions, for each a small rectangle you calculate the change in the velocity, and then you sum up. And if you sum all these rectangles area, you get what is the difference in the velocity or what is the change in the velocity between time interval t1 and t2. We can also calculate change in velocity using analytical approach, and this is basically extension of the previous case. So in the graphical method I said, if you want to calculate change in the velocity in the x direction, then this is equals to average acceleration in the x direction multiplied by time interval delta t. Now if you want to calculate this change between time t1 to time t2, then you have to basically sum. That is, you have to consider summation of all the rectangular areas. Now the question is, what will happen if my delta t, that is time interval, goes to 0? Very small time interval. Physically this means if the time interval is very small, my rectangle will be very small. So area in that case I can calculate using integration. Basically first, if delta t tends to 0, this average acceleration in the x direction will become instantaneous acceleration. So if delta t goes to 0, basically in that case average acceleration in the x direction, this tends to instantaneous acceleration in the x direction. So now in that case basically I can calculate this change in velocity in the x direction using integration. So if we have discrete summation, so this is what? This is discrete summation. So you are summing one rectangle, second rectangle, third rectangle. So this is a discrete summation. But when you have delta t tends to 0, the discrete summation becomes integration. So this is the idea. So in that case, we can calculate change in velocity in the x direction simply using integration. So this is the sign of integration. And this average velocity or average acceleration in the x direction becomes instantaneous acceleration in the x direction. And the time delta t, since this is very small, this becomes dt. So I have to integrate ax with respect to t, and I have to integrate between time t1 to time t2. So that will give me change in velocity from time t1 to t2. So that is what here we have. When delta is very small, then the area under the curve can be calculated using the integral. So what we were doing that time? We were basically calculating the area under the curve. That was the rectangular area. So if you sum all these rectangular areas, that was the area under curve. Now if delta t is very small, then this discrete summation can be exchanged with the integration, and that's what we have here. That is ax dt, and I am to integrate between time t1 and t2. That will give me the change in velocity in time t1 and t2. So if my time t1, velocity at time t1 is v1 and velocity at time t2 is v2, then change in velocity I can write simply nothing but v2 minus v1. So this is v2 minus v1 is equals to integral t1 to t2 ax dt. So from here I can write v2 is equals to v1 plus integral ax dt time t1 to time t2. One special case, when time t1 is 0, then I can write simply v2 is equals to v1 plus 0 to t, let's say time t2 is t, then 0 to t ax dt. Basically ax is a function of time. So this expression I can use to calculate velocity at any time t2, where t1 is 0 and t2 is t, and velocity at time t2 is v2 and velocity at time 0, that is v1. So I can use this expression. This expression involves instantaneous acceleration. So I have to integrate the instantaneous acceleration, that will give me the change in the velocity, and I have to add the initial velocity to get the final velocity of the particle. So this was the procedure that we can follow to calculate the velocity. If the instantaneous acceleration is given, instantaneous acceleration as a function of time is given, then I can integrate and I can get the velocity. Now the next question comes, what we do or how we calculate displacement. We know now velocity as a function of time, and I have to calculate acceleration, displacement as a function of time. So we can use the same idea. That is, if I want to use graphical approach, we have to make a diagram. In this case, this axis will be velocity. So y-axis is my velocity and x-axis is the time. And then we have to basically take a small rectangle, and time will be delta t, very similar to the previous case. And then we have to use the concept of average velocity. So if you remember, we defined average velocity in the x direction. This is equals to change in displacement divided by change in time. So from here I can say delta x is equals to average velocity in the x direction, this multiplied by delta t. This is what? If I consider this point, so this is, so for this rectangle, so let us consider this rectangle. For this rectangular, this is the average velocity. So let us see, this is my average velocity in the x direction. And this is time, delta t, time interval. So if I multiply these two terms, I will get this area. That is area of this rectangle. So area of this rectangle, that is velocity and time graph. So this is velocity versus time graph. So area of this rectangle is nothing but average velocity multiplied by delta t. That will give me the change in displacement, delta x, between time interval delta t. And if I sum all this from time t1 to t2, that is, if I take all this area, if I sum all these rectangular areas, then I will get change in displacement between time t1 and t2. Now in a special case, as I said earlier, if delta t tends to 0, what will happen? If my delta t tends to 0, these rectangular will be very small. So these rectangles will be very small. So this rectangle, something like this. So this will become very small, very fine rectangle. So in that case, I can replace delta t with dt. What about average velocity in the x direction? I can replace this with instantaneous velocity in the x direction. So that is when we have delta t tends to 0. And also we can replace continuous or basically discrete summation with integration. So that is what the three changes we are going to do if delta t tends to 0. So in this way, basically now if I do all this modification, I can write delta x is equals to, since this summation becomes integration and this average velocity becomes instantaneous velocity and this delta t becomes dt. And I have to integrate from time t1 to time t2. So this will give me the change in position vector, that is change in displacement between time t1 to t2. So let's say at time t1 the object position is x1 and at time t2 the object position is x2. So if I plug this, delta x will become change in position, that is x2 minus x1, and this is equals to t1 to t2 vx dt. So from here I can write x2 is equals to x1 plus integral t1 to t2 vx dt. In a special case, if time t1 is 0, then I can basically write the same expression little bit modified form. So I can write x2 is equals to x1 plus 0 to time t2 is t1. Time t2 is t, let's say time t2 is t, then I can write x2 is equals to x1 plus 0 to t vx dt. So I can use this integration to calculate position of the particle at any point of time t, and that is given by x2. So in this video we have seen how we can calculate velocity and position of the particle if acceleration vector is given, that is a function of time. So there are two approaches. One approach is graphical approach, another is analytical approach. We will use analytical approach in the coming videos. So in case of analytical approach, what we do is we use advantage of integration. So when you have discrete summation in case of delta t tending to 0, it becomes a continuous summation. So we use this fact and then we can calculate velocity and position as a function of time. And I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. For the time being, bye, take care. Hello friends. In the last video we have seen how we can determine the position and velocity of a particle when this is moving with a non-uniform acceleration. That is, if an object is moving with a non-uniform acceleration, we cannot apply a formula, that is s is equals to ut plus half at square, v square is equals to u square plus 2as, or v is equals to u plus at. So we have to do this by integration. So when an object is moving in a straight line, if I want to find what is the x coordinate, what is the velocity of that object, and acceleration is not constant, in that case I will use method of integration to find position and velocity of the particle. And what is given in such kind of situation, instantaneous acceleration is often given. So if you know the instantaneous acceleration, you can calculate the velocity, and from velocity you can calculate the position of the object. So this problem is called motion with changing acceleration. So the statement of this problem is, Sally is driving along a straight highway at t is equals to 0 when she is moving at 10 meter per second in positive x direction. She passes a signpost at x is equals to 50 meter. Her x acceleration as a function of time is given by this expression. That is, ax is equals to 2 meter per second square minus 0.1 meter per second cube times t. Now the question says find her x velocity vx and position x as a function of time. So we have to find her position and her velocity as a function of time. Now in this problem, acceleration is given. So this is the instantaneous acceleration. So you see, the instantaneous acceleration is a function of time. So this means acceleration in the x direction is not constant. So I can say acceleration is not constant. So this acceleration is not constant. So now I cannot use those formulas, that is the three kinematical equations that we derived earlier. So in this case, constant acceleration formula is not valid. We cannot use that. So what we have to do is, we have to solve this problem using integration. So we have to apply integration. If you remember, in the last video we derived formula for change in velocity in the x direction is equals to acceleration in the x direction multiplied by dt, and then you have to integrate from t1 to t2. Now let us say what are the things that is given in the problem. So it is given that is when c is moving at 10 meter per second in positive x direction, c passes a signpost at x equals to 50. So let's say initial position is given, that is x1 is equals to 50 meter, and this is at t1. t1 is 0. So 0 second, let us start, we start time from 0 second. And initial velocity is given, that is 10 meter per second. So we know, let's call at t1 velocity is v1, that is 10 meter per second. We have to find at any time t2, let's call t2 is equals to t, what is my velocity? So let us plug the acceleration in this expression. So we have delta Vx, and this is equals to integration t1 to t2, and acceleration in the x direction is given by this expression, that is 2 meter per second square minus 0.1 meter per second cube times t, and this has to be integrated from t1 to t2. So let us perform this integration. Delta Vx is nothing but v2, that is the velocity at time t2, minus v1, that is velocity at time t1. Now this integration is relatively simple. So this is constant term and integrated with respect to t. So this will become 2 meter per second square multiplied by t, minus this will become 0.1 meter per second cube, and integration of t is t square by 2. And basically at this point of time we are using a formula, that is integration of x raised to the power n is equals to x raised to the power n plus 1, and this divided by n plus 1. So if I use this formula, integration of t will be t square divided by 2. Now I have to integrate this between two limits, t1 to t2. So let's put t1 is equals to 0 and t2 is equals to t. So we want to find what is the expression of velocity as a function of time. So if you integrate this, this will become v2 minus v1, and now upper limit is t, so plug value of t, so the same expression you will have, that is 2 meter per second square times t minus 0.1 meter per second cube, and this is t square divided by 2. Now once you put t is equals to 0, this whole expression will be 0. So this minus 0, which has no meaning basically, so there is no need to subtract 0. So now I know velocity as a function of time, that is v2 is equals to v1 plus, and v1 I know, what is v1, that is 10 meter per second. So I can plug this value, so that is 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube t square divided by 2. So this is the expression of velocity at any point of time. Now you have seen that if I integrate acceleration, I get the velocity. Now the second part of the question says you have to also calculate position. So this means I have to integrate velocity now. So if you remember, for position we have expression delta x is equals to integral Vx dt, and this goes from time t1 to time t2. So at time t1 position is x2, so delta x becomes x2 minus x1, where x1 is the position at time t1, and this is equals to Vx dt t1 to t2. And now I know expression for Vx. Vx is nothing but v2 at any point of time. What is the expression for velocity? That is this expression. So I can plug this expression. So x2 minus x1 is equals to time starts from 0 to t. t2 is t, t1 is 0. And Vx is this expression, that is 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube t square, and this divided by 2. I have to integrate this with respect to time. So now if you integrate this, this will be x2 minus x1. This is equals to, so this is a constant, so this will be multiplied by t. And then this is t, integration of t is t square by 2. So this is t square by 2 minus 0.1. This is 0.1 meter per second cube. And integration of t square is t cube by 3. And we also have 2. So this becomes t cube by 6. And this we have to integrate between limits 0 to t. So you see, if I plug t equals to t, I will have the same expression, and when I put t equals to 0, I will have 0. So this is simply x2 is equals to x1, and what is x1? It is given in the problem, that is x1 is 50 meter. So at time 0, the x1 is 50 meter. So I can plug this value. So this becomes 50 meter plus 10 meter per second times t plus 2 cancels out, so I will have 1 meter per second square t square minus, I can write 0.1 meter per second cube divided by 6 and t cube. So this is the expression for position at any point in the future at time t. So this is the first part of the problem in which we calculated position at any time t and velocity at any time t. Now the second part of the problem says when is her x velocity is greatest. So when we will have maximum velocity in the x direction. So if you have some idea of calculus, if I want to have Vx is maximum, then, and Vx is a function of time, then I have to satisfy this condition, that is dVx divided by dt or dVx over dt is equals to 0. So this is the condition for maximum. And you have to also show that d2Vx divided by dt square, this is negative. So this is the condition for maximum. So if I plug this, that is dVx by dt is equals to 0, from there I can get time when this will happen, and dVx by dt is nothing but acceleration. So basically what we have to do, we have to simply put x equals to 0, and from there I can find the time when her velocity will be maximum. So corresponding time will give you the maximum velocity. So what was the acceleration? So if you remember, expression for acceleration is x is equals to 2 meter per second square minus 0.1 meter per second cube into t. So this was the expression for acceleration. So we have to equate this with 0. So if you equate this with 0, you will have t is equals to 2 meter per second square divided by 0.1 meter per second cube. So this will be 20 seconds. So we will have after 20 seconds, that is t is equals to 20 seconds, the velocity will be maximum. So at this point of time, velocity is maximum. Now next part of the problem says what is the maximum x velocity. So we have to find what is the velocity at time t is equals to 20 seconds, because maximum velocity occurs at t is equals to 20 seconds. What was the expression for velocity? If you remember, we earlier calculated expression for velocity, that was basically v2. General expression for velocity was 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube, and this multiplied by t square by 2. So this was the general expression for velocity. This means now if I put t is equals to 20 seconds, I will get the maximum velocity. So what is this value? So this is 10 meter per second plus 2 meter per second square, and time is 20 seconds minus 0.1 meter per second cube, and this is 20 second square divided by 2. So this is equals to, if you calculate, this will come 30 meter per second. So this is the maximum velocity that C will attain, and this will be attained at time t is equals to 20 seconds. Now the next part of the question says where is car when it reaches its maximum velocity, x velocity. So we have to find what is the x position when it reaches the maximum velocity, and you remember that b maximum happens at t is equals to 20 seconds. So this means I have to calculate x at time 20 seconds. So position at 20 seconds. So if you remember, we have expression for x coordinate, that is x2. So we derived this expression, that is 50 meter plus 10 meter per second times t plus half 2 meter per second square, and this is t square minus 1 by 6 0.1 meter per second cube, and this is t cube. So this was the expression that we derived for position at any time t in the future. Now what is x? So we have to plug time t is equals to 20 seconds. So this means 50 meter plus 10 meter per second multiplied by 20 seconds, because time is 20 seconds, plus half 2 meter per second square. So this is 2 meter per second square multiplied by 20 second square minus 1 by 6 0.1 meter per second cube, and this is 20 second raised to the power 3. So if you calculate all this, you will find x is equals to 517, that is 517 meter from the x equals to basically at time t is equals to 20 seconds. So we can find what is the x coordinate at time t is equals to 20 seconds, and this will be 517 meter. So we calculated the x velocity, x position, and maximum velocity, and what is the time and when this maximum velocity occurs. Now let us try to plot all this. So we will first plot acceleration. So we will first plot acceleration, that is ax. So what was the expression for ax? If you remember, ax was 2 meter per second square minus 0.1 meter per second cube times t. So this was the expression for acceleration. If I want to plot this, let us say I have, this is my x-axis and this is my y-axis. On the x-axis I am plotting time. So time is on the x-axis, and on the y-axis we have acceleration. So x-axis is time and the y-axis is acceleration. How this graph will look like? So this is the equation of line, and when t is equals to 0, what is acceleration? 2 meter per second square. So if you plug t is equals to 0 in this expression, acceleration is simply 2 meter per second square. And now this is a straight line. So this is a straight line, it will go something like this. So we can show negative y-axis also. So this is the acceleration. So important point, you see up to this point of time, basically we can calculate this time. When the acceleration is 0, that is x is equals to 0, then if you plug this, you will find t is equals to 20 seconds. So at t is equals to 20 seconds, acceleration is 0. Before this time, acceleration is positive, and after this time, acceleration is negative. This means before t is equals to 20 seconds, the car is speeding up. So this is a case when car is basically speeding up. And after this time, acceleration is negative, so a speed is decreasing, so slow down motion. So this is a case where the speed is decreasing and this is slow down. And at time t is equal to 20 seconds, you have maximum velocity. That is, acceleration is 0, this means maximum velocity increasing and then start decreasing. This means you will have maximum velocity at t equals to 20 seconds. Similarly, let us try to plot velocity in the x direction. So we have expression for velocity, and this expression is 10 meter per second plus 2 meter per second square times t minus half of 0.1 meter per second square t square. So let us plot this. On the x-axis we will have time, and on the y-axis we will have velocity in the x direction, that is Vx. Now what is velocity at t is equals to 0? So if you plug t equals to 0, you will find Vx is 10 meter per second. So Vx is 10 meter per second. Now what kind of this graph? So this is a graph of parabola as a function of t square. So this is a graph of parabola. Now we also know at t is equals to 20 seconds, velocity is maximum. So somewhere here, at this point, velocity is maximum. So this means velocity is increasing and then velocity is decreasing. So I can plot the graph. So this should look something like this, because this is a parabolic in nature. So that's why this velocity will something like this. So you can see the first velocity is increasing and then it is decreasing. So velocity is increasing. In this case, in the first case, it is increasing up to t is equals to 20 seconds, and after t is equals to 20 seconds, velocity is decreasing. Basically, you can find at what time its velocity will be 0. In that case, what you have to do? You have to put this expression is equals to 0 and then you have to find value of time. So plug Vx equals to 0 and then you find time, and this will give you expression for time or value of time where this is going to cross the x-axis, that is time axis. So I leave this problem for you. You try to solve this and put the answer in the comment box. Now finally, I can also plot displacement or position as a function of time. If you remember, we have position as a function of time, that is basically x2. x2 is nothing but position as a function of time, displacement as a function of time, and the expression for this is 50 meter plus 10 meter per second into t plus 1 meter per second square, and this multiplied by t square minus 1 by 6, 0.1 meter per second cube tq. So this is a cubic equation. So if I want to plot this, on the x-axis we have time, and on the y-axis we have position, that is x coordinate. Now what will the position at t is equals to 0? So this corresponds to t is equals to 0. You will have velocity, or not the velocity, position, that is 50 meters. So this graph will start somewhere here. Let's put this, or let's put somewhere here. So this is x is equals to 50 meters. So this graph will start this point, Now this is a cubic function. Now you see, in cubic function we can decide whether this is concave up and whether this is concave down depending upon d2x by dt square value. So d2x by dt square, this is nothing but dvx by dt, this is nothing but acceleration. So if my acceleration is positive, then we will have concave up, and when acceleration is negative, we will have concave down. And at what point you have acceleration is equals to 0? So this means, if you remember, we said for t is equals to 20 seconds, the acceleration is 0. And before that time acceleration is positive, and after that time acceleration is negative. This means at t is equals to 20 seconds, we have point of inflection. That is, curve is changing its nature. Before 20 seconds, we have concave up. So concave up, this means something like this. And then after this, we have concave down. So concave down, something like this. So you see, so this is concave up to this point to this point, and then this point is a point of inflection, t is equals to 20 seconds, and this curve has changed its nature, and this becomes concave down. So in this case, I can say this is concave up and this is concave down. So curve has changed its nature. So this is the position time graph. So in this video we have seen how you can calculate velocity and position if instantaneous acceleration is given. So first is, if you integrate acceleration, you will get the velocity, and once you have the velocity, you can integrate further to get the position. And once you have expression for velocity and position, you can find at what point of time you have maximum velocity, what is the x coordinate at given point of time in the future, and you can also plot the graph of acceleration, velocity and displacement as a function of time. In this case, the acceleration graph is linear, velocity graph is parabolic, and the displacement graph is cubic, that is 3-degree graph. Third order cubic equation, third order polynomial. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video with some more interesting topic. So for the time being, bye and take care.